Hi everyone. In chapter 2.1, we started learning about sets and elements of sets. We are taking that to the next level in 2.2. We're going to talk about subsets of sets. What are we supposed to learn? If you look over here at the left-hand side, we have number one, we're going to recognize subsets and use the correct notation, recognize proper subsets and use the correct notation, and determine the number of subsets of a set, and apply concepts of subsets. So, you okay? So, math tattoos. Who knew? Emerging from their often unsavory reputation of the recent past, tattoos have gained increasing prominence as a form of body art and self-expression. My sister has a math tattoo. A recent Harris poll estimated that 45 million Americans, or 21% of the adult population, have at least one tattoo. Table 2.3 shows the percentage of Americans by age group with tattoos. So remember, sets could be categories of things, and a lot of times that's how we use them in the real world. The categories in the table divide the set of tattooed Americans. So if we just look at that 21%, we could make subsets. So of that 21% of, and I'm going to go to this table, of that 21% of people that have tattoos, 22% of those people tattooed are between 18 and 24, 30% between 25 and 29, 38% between 30 and 39. Then it starts getting lower and lower. So that's interesting. I wonder, it looks like it's going down, like young people today aren't getting as many tattoos, or the reason people in their 30s have more tattoos is because they're just older. They've had time to get more tattoos. So that's interesting. Subsets, it gives a specific definition here. Situations in which all elements of one set are also elements of another set. The math definition, set A is a subset of set B, expressed as A is a subset of B, if every element in set A is also an element in set B. Okay. So let's go on. Please feel free to read that slowly and again. But if everything is in A, everything in B is in A, or A, well, this is exactly what we're getting into. I won't try to say it right now. So we're applying this definition to the people that have tattoos. So we have the set of tattooed Americans in the 25 to 29 age group is a subset of the set of all tattooed Americans, right? Everyone in this group of tattooed Americans who are 25 to 29 is a smaller set, okay, a smaller group of all tattooed Americans. Now, let's see here. We're just going to do it with numbers. So this says if A is the set 1, 2, 3, and B is the set 1, 2, and they are saying that A is not a subset of B. A is not a subset because A has a 3 and B does not have that 3. Now, B is a subset of A, right? But that's not what they were asking. So if it's not a subset, you need to put that slash mark through your symbol there that means subset. Easy enough. So we're looking at examples. Write subset or is not a subset in each blank to form a true statement. So here A has 1, 3, 5, and 7, and B has 1, 3, 5, and 7, and also 2 more. So that's fine. It can have more as long as A contains all of those original numbers, elements. So A is a subset of B. A is actually a proper subset of B, but we'll get into that next. If A contains all the elements X, where X is a letter in the word proof, so that means A contains P, R, O, O, and F. And actually, I'm not going to write O twice. And B is roof, R-O-F. We can see that A is not a subset of B because A has more elements than B does. If A is equal to the elements X, where X is a planet in Earth's solar system, and B is Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, then A is a subset of B, and in fact, they are actually equal to each other, too. Everything in A is also in B. You can read through their solutions more slowly if you would like. So for your checkpoint, same thing. We are going to write, is A subset of B? So in this first one, I think it's pretty easy to tell since A seems just visually bigger than B. Let me read this to you. Oh, it's the same question that we just had, except flipped. Okay, so does that change your answer? And if A contains elements X, where X is a day of the week, and B is Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, that's going to match up with part C that we did above. Proper subsets. So this is what I was saying before. In order to have a proper subset, you actually have to have less elements. It's not subsets that are equal to each other, okay? So even though it is a subset, if two sets are equal to each other, a proper subset, they're not equal to each other, right? So it gets down here and it says A, it spells it out for you. A is a subset of B. Every element in A is also an element of B. And A is a proper subset of B because A and B are not equal sets. So that's just exactly what I was talking about and what it says here in your mathematics definition, okay? And then it says, by contrast, there are subset examples where only the symbol is a subset can be placed in between sets. So if they are actually equal to each other, then you're going to need to use this one. All right, so right is a subset, is a proper subset, or both, in each blank to form a true statement. So A is the set of X, where X is a person and X lives in San Francisco. And then B, X is a person and X lives in California. So the question is, does everyone who lives in San Francisco also live in California? And if your answer is yes, then A is a subset of B, and it is also a proper subset because people who live in San Francisco is a smaller amount of people than who live in California. And then the second one, B, A is 2, 4, 6, and 8. B is 2, 8, 4, and 6. Since they contain the same exact elements, A is a subset, but is not a proper subset because they have the exact same amount of elements. Okay. You can read through the book solution more slowly if I didn't give you enough information. So checkpoint 2, the same thing. Is A subset of B? And if so, is it also a proper subset? And B, X is a person that lives in Atlanta. X is a person who lives in B. X is a person who lives in Georgia. So the question you're asking yourself does everyone who lives in Atlanta also live in Georgia? You okay, Arnold? All right, feel free to read through the book. It has some more information for you. Subsets in the empty set. The meaning of A is a subset of B leads to some interesting properties of the empty set. So the property that you're learning about the empty set is that the empty set is a subset. So the empty set, I should have written that. Sorry, you guys, like that, is a subset of every set. Okay, so that's the rule. If A is an empty set and B is this set, is A a subset of B? Yes, because the empty set is a subset of every point of every set. So I think you'll have a pretty easy job with checkpoint 3. This table is important. It just simply means if this is it's a way to figure out the number of subsets a set has. So you look at the number of elements a set has, you make it the exponent with a base value of 2, and that will give you the number of subsets. So if there's 0 elements, or if there's, if there's 0 elements, then there are 0, then there's 1 subset, right? The empty set. If you have 1 element, you have 2 subsets. If you have 2 elements, then you have 4 subsets. The number, and then it says it right here in words, the number of distinct subsets within a set with n elements is 2 to the power of that number of elements. The number of proper subsets, remember you're going to have to subtract, it's the same thing, but you subtract 1 because you are subtracting the actual subset, which is not a proper subset. The actual set, which although it is a subset, it is not a proper subset. Find the number of distinct, so let's do some examples. Find the number of distinct subsets and the number of distinct proper subsets for each one. Hold on, let me go turn this off real quick. All right, so A, you can tell there are 5 elements, so the number of subsets is going to be 2. Oh, wants proper, sorry. 2 to the power of 5 and then minus 1. So 2 to the power of 5 is 32, minus 1 is 31 proper subsets. And our second one, we have to look at how many elements are in here. Well, we have 9, 10, 11, 12, 14, and 15. So 1, 2, 3, 4, 5, 6, 7. So 2 to the 7th minus 1. So 2 to the power of 7 is 128 minus 1 is 127 elements, proper subsets. So if a set has 7 elements, it will have 127 proper subsets. So in this checkpoint, find the number of distinct subsets. So you're doing it 2 times. Distinct subsets, which is just 2 to the n, and the number of distinct proper subsets, which is 2 to the n minus 1. A, I don't think I need to help you with it. I will say that B, let's write out the elements of B. It's going to be 3, 4, 5, 6, 7, and 8, because that says where x is greater than or equal to 3 and less than or equal to 8. All right, so now it's talking about the number of subsets of infinite sets, okay? It says once we accept the cardinality of sets with infinite many elements, a surreal world emerges in which there's no end to an ascending hierarchy of infinities, which is interesting. I think we've touched on this in math class in high school in the past by saying, like, if you're looking at, there's an infinite amount of numbers, but then if you're looking at just between the numbers 1 and 2, there's also an infinite amount of numbers. So there's two different infinities. Is one a subset of the other one? So it's talking, that's what it's getting into, is infinite sets. Oh, and it doesn't actually ask us, whoops, sorry guys, it doesn't actually ask us to do any examples of that. So just a little reminder, there are different types of infinities. All right, let me know if you have any questions.